This video is all about how to deal with some of the more awkward double angle formula questions. Hopefully you've had a go at some of the easier ones now, like the one at the end of the last video. But we've called them tweaked double angle formula questions. Questions where these don't look like you can use the double angle formula here, but by doing a little tweak, we can use the double angle formulae, or maybe even the addition formulae. So at the top here is a summary of all the formulae we've come across so far in the previous videos. So let's have a look what to do if we see a sine 3x anywhere. So when you have sine 3x, the way to deal with that is to always write that as sine brackets 2x plus x, and then you can just use the top addition formulae. So you would then just let a equal 2x and let b equal x in the top addition formula there. So that's how you would deal with that. Whenever you see a sine 3x or a cos 3x or a tan 3x, you need to do it that way. Often it helps you in the question. It tells you to do that, but it might not. So be aware of that. If you ever see sine 4x, the way to think about that is the same as this. So if you look at this formula here, let's just write that down above it. So we know that sine 2x, sorry, sine 2a, we'll call it, sine 2a is 2 sine a cos a. And so if we let a equal 2x into the equation I've just written down, then we will get an equation for sine 4x, because we put 2x in here and we get the 4x we need. And so we then have to put a 2x in here and 2x in here. So sine 4x is quite simple actually. Sine 4x is just 2 sine 2x cos 2x. And looking at the last one here, so this time it's sine squared x over 2. You might need to change that into a different expression. So how you could deal with that is by looking at this one here. Look at cos 2a equals 1 minus 2 sine squared a. So if I write that down, that cos 2a is 1 minus 2 sine squared a. You can see that in this question, if we let a equal x over 2, when we put x over 2 into here, we get the sine squared x over 2 that we need. So if we just go from the top equation down to here, so if we put x over 2 in there, we will get cos of 2 x over 2, which is just going to be cos x. It's going to equal 1 minus 2 sine squared x over 2. And we want to get sine squared x over 2 on its own, so we could just rearrange this now. If we rearrange this, we'll get, let's scroll down a bit, if we rearrange this, we will get sine squared x over 2 equals 1 minus cos x all over 2. So that is helpful to do that sometimes. If you want to see where these things we've just done up here are useful, then have a look at page 181, question 14, and page 188, question 4, for questions like this. You can see the example below for an example where you need to use what we've done there with sine 4x, and for an example like this one, you can see page 181, question 12, or you could see page 188, question 5. So let's have a look at an example where we need to use one of these. This example here, we're going to need to use what we've done up the top. So if we replace the sine 4x with 2 sine 2x cos 2x, that's going to be a good start. So we'll do that. Okay, now we'll just multiply that out. So that's 6 sine 2x cos 2x. Now whatever you do now, don't be tempted to cancel the cos 2x's, because then you'll lose the cos 2x equals 0 solutions. So what you have to do now is get everything on one side and factorize. So if you get everything on the left hand side and factorize, we'll get cos 2x bracket 6 sine 2x minus 1 equals 0. So then all we need to do now is we solve cos 2x equals 0. We need to solve that, and that will give us solutions. It doesn't actually say a range here, so we'd need to, the proper exam question would give us a range of values and also tell us whether we're in degrees or radians or not. But this is just to give you an example of a question where we need to use the sine 4x identity we've just found. Also, we would need to solve sine 2x equals 1/6, and I think that would give us, I got 4.8 degrees and 85.2 degrees. But again, you would be told what range you would need there. Just to finish off, here are 3 questions where you might need to use the double angle formulae. You might need to use the double angle formulae but tweaked a bit, as we just discussed a minute ago in the previous examples, or you might not need the double angle formulae at all for these. So you might want to pause the video and just think, how would you work out the answers to these 3 questions? How would you go about doing the first few steps in the solutions? The first one, sine 2x equals cos 2x. I hopefully you realize that if you just divide both sides by cos 2x, you will get tan 2x on the left hand side and 1 on the right hand side. So then you can just solve as normal. And you could have done that question last year in using year 1 trigonometry. So for that one, we didn't need any double angle formulae at all for that one. Let's have a look at the second one. So number 2. I think the way I would do that is to think about the double angle formula for cos. If we were to let a equal 3x, then the formula we've got there will just become cos 2a equals cos 3. Now, then we can just use the double angle formula for cos 2a. So that would be 2 cos squared a minus 1 equals cos a. And that can just be rearranged to get a quadratic in cos now. So that's 2 cos squared a minus cos a minus 1 equals 0. And we just solve the quadratic as normal. Solve the quadratic to find a. But don't forget, we would then need to divide by 3 to find x. Now the last one, so that second one, that was a tweaked double angle formula question. And for the third one, tan 2x equals 3 tan x. I think you can just go straight to using the double angle formula for tan 2x here, which would make this question 2 tan x over 1 minus tan squared equals 3 tan x. And then just rearrange. So you're going to get 2, if we multiply both sides by this denominator here, you're going to get 2 tan x on the left, and that's going to equal 3 tan x minus 3 tan cubed x. And so again, it's similar to the example we did earlier. Don't be tempted to divide by tan x, or you'll lose the tan x equals 0 solutions. Instead, get everything onto one side. Let's get everything onto the left hand side. So that's 3 tan cubed x minus tan x equals 0. And factorize, so tan x is 3 tan squared x minus 1 equals 0. Tan x equals 0 then, so we need to find all the solutions in our range for that. Or tan squared x equals 1/3, which means that tan x will either equal 1 over root 3, or let's just move down a bit, not that much, or tan x will equal minus 1 over root 3. So we would then just go on to solve this in the given range, this in the given range, and this in the given range. So this last one here was just a straightforward double angle question.